Good day, participants. My name is Zoe Whitley. I'm the Regional Marketing Manager for Anglophone for IDEA Technologies. Thank you for joining our webinar today. We are about to start. Our webinar today is on technology in road construction webinar, to push boundaries and survey with confidence. I'd like to thank you for joining us today, and also to just pass over to our two engineers, account engineers who will be presenting today. Mawad Zarid, he's a survey engineer based in Morocco, and Elijah Oching, who is also a civil engineer based in Kenya, and they will be presenting the webinar today. So Mawad, over to you.
Thank you, Zoe. Hi, everyone. Thank you for joining us today on this webinar. So as the title shows in this presentation, we will be talking about surveying from a BIM perspective. We will present workflows that bridges the gap between the design and the construction in the field, and also make the coordination between the office and the construction site smoother and easier. So I'll start by presenting our technical leaders. We have a team of experienced and highly skilled technical staff. These leaders are in the service of the African continent, and they have been selected to support and enable you to win in their respective fields. And these guys also are the sales support team. So we are working mainly on 5 segments: the complex and vertical building segment, roads, highways, bridges and tunnels, mining, machinery and industry plant, water and manufacturing. So for the webinar presenter, we have Elijah Oching, which is a technical account manager, civil engineer, and he specialized in the infrastructure, and he is experienced in this industry. Elijah also is skilled in structural design, construction project management and coordination. And you have myself, Mawad Zarid, survey engineer, technical account manager. Before joining ID8, I was working as a surveying manager for civil works at a big multinational company in Morocco. And I have a very big passion for technology. So to start, what is BIM? There are practically as many definitions of BIM as user, but it is defined by International Standards Organization as a shared digital presentation of the physical and functional characteristic of any constructed object that provides a reliable basis for decision. In other words, it's a 3D model associated to a database that provides every information you need to know about a building. Depending on the project, BIM has several interveners. In the road construction, for example, there is the structural designer, the road designer, land surveyor, project manager, etc. But as I mentioned earlier, we'll be talking more about BIM from a surveyor perspective. So the land surveyor will be our main character. Now moving to the workflow objectives, there are mainly 3. The first one is the design using Autodesk InfraWorks, Civil 3D, and AutoCAD. And then we have the export using Topcon Magnet Enterprise. And after that comes the layout using Topcon GT robotic total stations, Topcon Genesis systems, especially HyperHR, and Topcon FC5000 field computer. So to talk a little bit about the background and the value proposition, BIM-based layout is a process that provides accurate point coordinates directly from BIM models that the field teams can use to reduce the risk of layout, increase office to field accuracy, and get more done. This process enables constant comparison of what was done in the field to the design that needs to be done. So data from the model in the office and the surveying instrument in the field can be imported and exported to capture the as-built conditions. Sending data to and from the field in a very short amount of time improves speed and accuracy of installations. Storing positions enable quality control and insurance. So this process effectively bridges the gap between the office and the field. BIM-based layout processes are the perfect solution when a massive amount of asset data needs to reach the field in a short amount of time. So there is no need to waste time using classic methods, such as printed drawings and field books that are often time-consuming, tedious, and error-prone, which can set back projects and timelines. This is the first part of the workflow details, which is adjacency. In this workflow, we will be combining Civil 3D and maybe InfraWorks from Autodesk and using GT Robotic Total Stations, HyperHR Genesis Systems, and FC5000 field computer with magnet field on board from Topcon. So Autodesk Civil 3D software is a design and documentation solution for civil engineers that supports building information modeling. The use of Autodesk Civil 3D improves project performance, maintains consistent data, and follows standard processes and responds faster to change. Magnet Field is a very powerful software that is used to collect survey data and perform construction and draw layout using total stations, GNSS receivers, and levels. And Enterprise is used to connect field to office and send data and get results in real time. We have also 7-inch display specifically designed for visibility in under sunlight. The FC5000 field computer is built with IP68 environmental rating, which make it very strong. The FC5000 is capable of operating in temperature between -20 to 50 degrees. This unit is built for speed with a Nantel Atom Z3735 processor that drives any Topcon software with ease, and it is ready to work with large design file. We have the GT Robotic Total Station that are high performance solution that enables to get the efficiency of a single operator robotic system, the power of long range reflector measurements, and the ability to perform as a hybrid positioning solution. And all in a compact system that's small and fast. Ultrasonic technology is the driving force for the GT series. The ultrasonic motors are the fastest available on the market at 180 degrees per second. It is the smoothest and the most accurate prism tracking available. The HyperHR is the most advanced Genesis technology available right now, combining next generation fence antenna for superior reception, waterproof IP67 environmental rating, long range and radio communication, all integrated with the 452 universal tracking channels and the unique 9-axis tilt compensation. So after seeing all the products that we will use in this workflow, let's start what really matters, how to get things done. So after finishing the design and establishing the fieldwork process, this design part, we will see it after with my colleague Elijah. We export the points directly to Total Station or Genesis Systems via Magnet Enterprise, or share them on BIM 360 platform as a task attached to the project and assign it to the appropriate person. BIM 360 workflow, we will see it in another workflow that we are currently working on. So then we lay out the points in the field. So how can we bridge the gap between the field and the office? An image worth 100 words and a video worth may more. So in this video, we will discover Magnet Enterprise, which is a very strong tool to send data to and from the field. Enterprise allows users to exchange the data from the office to the field and from the field to the office. And its interface is very friendly. You start by creating a project, introducing all the information you need to know about the project, its name, etc., and choose the user access and specify the team that can, and the persons that can get access to this kind of information. After that, you get to upload your data. You upload the coordinate list, PDF, documents, etc. And when you upload, you can change the format, you can visualize the documents, and you can convert the documents on any format you want from the available format. And you can convert it very easily. And you can visualize your data on a map. So if you have, for example, to stick out some lines on a road, you can visualize your lines before sticking them on a map. And then you can get access to Magnet Enterprise from the field to download the data that has been uploaded in the office. Here you choose the name of the project and you have all the data that has been uploaded in the office. You can also see it on your tablet in the field. You can see the data that needs to be staked out on a map. And this is not the only things. You can start chatting with the persons in the, for example, if there is some question that need to be answered from the office, you can send questions from the office or send questions from the field to the appropriate person. For example, here we have a person that is writing a message to the person in the office to ask him about something, and the other person in the office, once he get the message, he can reply either on the chat box, or he can add directly notes to the map. So the following step is to lay out the construction. In this video, we will see step by step the workflow of staking out points using JT Robotic Total Stations. So I'll start with importing design points to lay out. To do so, the magnet field menu is very friendly, very easy. You click job, then you choose from where you want to import your file. Here we have different options, and you get to confirm the data format. Then you choose the file from where you want to get the coordinate points to stake them out. Once you have successfully imported your coordinate, you are ready to start staking out. You click stake, and what is good about this software is that once you choose your point to stake out from a list of all the points available on your machine to stake out, the machine is here. You have all the points that you can choose from to do the stake out. Once you have chosen one, the machine in the field turns automatically to the right angle. So without trying to reach the angle, it does that automatically, and it helps you with the lights. The red lights mean go right, and the green one means go left, and the yellow one means the center, stay in the center. So clearly visible guidelines guides the prism man to the center of the design line. In here, you keep navigating the prism man to the design point, and once he is on the right position, you give him instruction to stop and to stick that point. So thank you all. I'll pass to my colleague Elijah so he can present the design part. Elijah, could you please share your screen?
Thank you, Moed. So mine comes from a design perspective because before you start doing your surveying and construction on site for laying out those points or the points to be staked out, there must have been information that were passed to the surveyor from the designer, specifically based on the route or the corridor along which the particular design should follow. So like with me, I'll just illustrate a very simple procedure of how you link up Civil 3D, InfraWorks Civil 3D, and generate the staking out points report that can be used by the surveyor out there in the field to do their layout using either total station or any other preferred equipment. So I have a very good concept here, basically showing a road corridor within a road reserve that has been designed. But I will illustrate how easy it is once you have got your model ready within InfraWorks to do a concept, after which you convert that concept into a preliminary design. Then we take our preliminary design from InfraWorks into Civil 3D just to check on some level of detail in terms of the design criteria, maybe the curve length, the curve radius, if they meet the minimum design requirement based on that particular area of the project where the design happens. So we all know with InfraWorks, you are able to create different design proposals. So like what you are seeing right now is more of my final design at the preliminary level, but I will start from scratch just to illustrate, starting from an open field, or maybe for an improvement of an existing road to a higher class of road. Then after that, we'll develop it into a concept, a detailed preliminary design output that I will link up with Civil 3D to generate its detailed design. So like you can see here, we have got a very good detailed GIS information in terms of the imagery, the terrain model, and also the shape models for the buildings, how they exist on that particular project area within the InfraWorks. So basically you need to bring that in. If you know also of late, right now it is possible to link up InfraWorks with the ArcGIS. So like if I wanted to link it with ArcGIS to bring in those different detailed information, I'll go to the GIS connector, which will open up the ArcGIS online that can now allow me to start working and bringing in the GIS information just to build the context of my model. If I want to know maybe this is the road reserve, these are the adjacent buildings that the project will affect, then I can now start doing my proposed corridor alignment. So I want to go into that because of time. So, but you can see the various GIS information that I was able to bring in terms of the building, the images, and even underground utilities in terms of the existing sewer line, the pipe networks, and all those other related project context. So also you can be able to do different design alternatives and come up with the one which is most feasible. So for this purpose, I want to go into that detail, but I'll just illustrate how we can start by sketching our road within a proposed corridor. So like I'm having this corridor here, which I want to do a road. So currently the road which exists there is 2 lane, 1 in each direction, but we want to lay it and upgrade it to dual carriageway, 2 lanes in each direction. So InfraWorks makes doing that concept very, very easy in terms of using the 3D road layout tools, where as I lay it out, I'll be able to see the various lengths, the curves that I propose to have, and following a specific predefined route for the road. So I'm sketching on 3D So as opposed to using CAD to draft for this, I will easily lay it out as I see the context. Maybe if there's a specific path that the road will follow, I'll build it easily. And maybe, like in this case, I want to cross over the river to link up the two different parts of this town. I'll go up that particular area, then turn up and follow again still this land here, open land here, and link it up with this other side of the city. So that's basically the process of laying out the roads using tools that InfraWorks provides us with. So I first lay it out as a sketch. Then after that, I can now start adjusting to also help me minimize the number of the curves and the tangent point that I will have along my road. So like in this case, I only want to have one straight point here. So I will remove this vertical point here, the vertex, sorry, and also remove this one here. So I remain only with one straight point plus one intersecting point of intersection along that road. So basically I'm starting, as you can see, is very, very easy, and I'm doing it based on the context of that particular project. So this, the first process is supposed to do after having built up your GIS data to form up the model, giving the context on where the design should be done. So after having done this, so maybe I'll assume my alignment follows the path that has been prescribed. So once it is within that path that we intend the proposed road reserve or the corridor that it should be done, I will now convert into a preliminary road, a road where I can now have advanced control in terms of the curves, in terms of the design, in basically like if you're talking about a design speed of 60 kilometers per hour or 50 kilometers per hour, I should now be able to see if all those curves meet the minimum design requirement and even specify the class of the road. So what we do in that case, I'll just right click, well, with that road selected, I'll right click and convert into component. So component basically is an equivalent to a preliminary design road, which allows you as a designer to now start having control in the road geometry. So you can see immediately it's converted to a component road. We can now start looking at the various stations along the road, the curves, and also we can also be able to look at the road in profile view. So like if I just right click, I can show the profile view of the road, and I'll be able to see how my proposed vertical profile compares with the existing ground. And also I should be able to see the geometry of my vertical curves. So whether they are circular curve, simple curves, or parabolic curves, I should be able to see that and the exact points of intersection within that vertical geometry of the road. So basically we all know that the difference between the existing ground and the proposed ground will dictate the amount of earthwork that should be cut or filled during the actual construction. So to again show, so you can see on the right sidebar, you should be able to see, it gives me the function or classification of the road. So by default, it classifies this road as a local road with an average design speed of 50 kilometers per hour. And basically, this is dictated by the design standard that you're using. So like in this case, my default design standard is set to design manual for roads and bridges, metric. So if I want to increase or change the class of the road, I'll just click to select, for example, from local road, it goes to local to collector road or class C. So if I change to class C, and therefore it now allows me to increase even the design speed of the road to, let's say, 70 kilometers per hour. And with that, I now need to start now checking to ensure my geometry, both horizontal and vertical, meet that design requirement for a design speed of 70 kilometers per hour. So if there's a specific section along the road where that particular design criteria is not met, the software will automatically tell us with an indication of a red color or a yellow color along the geometry. But if the sections passes those minimum requirements, it will automatically turn them into green. So like in this case, within this curve that is on the screen right now, you can see it is being turned yellow. And if I click on it, on the right sidebar, you can be able to see, it tells me when I put the cursor there that the geometrically possible range is from 0.1 to 58 as the radius of the curve. And this range is currently less than what is been specified based on the geometry that I'm having right now. So it basically means that if I need to make it to meet that requirement, I need to adjust the curve radius to allow the geometry to achieve the minimum set requirement. Well, basically we know that at the curvature point, we know the effect of the centrifugal forces, which can easily make the vehicle to maybe topple while negotiating such bends. So that's why you need to ensure that the radius specified or provided should allow for the vehicles to move within that particular design speed that is set. So in this case, the value I should provide for should be at least 173. Or alternatively, I can lower the design speed at that section to allow for that value to be met. And also sometimes based on the PIs, the point of intersection, the point of curvature, you may not be able to increase the radius because it will not be geometrically possible. So the alternative I have there is just to adjust the points of curvature to allow for that to happen. But if it's not possible because of the geometry that you are providing at a particular point, you may be limited by only being able to adjust and lower the design speed. So I will regenerate it because I still have to have that curve at that particular point to allow the transition from one point to the other. So what I may now need to do is just to lower the design speed maybe at 50 and see if that still violates the design criteria or not. So it is still violated, and I can see the value now. It's telling me the minimum value I require is 59. So I will try 60 and see if the curves, again, my geometry does not allow that. So you're supposed to go through that process until you reach to a point where there is no warning at any particular point. So I may need to remove this adjacent curve to allow me to enlarge this one. So I can now drag this from here. Still, it is still not coming out. So again, I just move this up to a point where the color disappears, just to show that my design criteria have all been satisfied. So I'm still adjusting that. So maybe I also don't need this curve at this particular point. So I'll just select and remove it. So I'll remove that curve. I only need one curve towards the end of the straight. So then after that, I'll be able to adjust this. So you can see immediately it reaches a value which is greater than the minimum. You can see now I'm no longer having the yellow color. So if I slide it lower, you can see it turns green. That means that I've specified a value of the curve which allows the vehicle to turn there or to maneuver within that curve without the danger of toppling. So then after that, if maybe there was a bridge within my road geometry, I can easily again now maybe add a bridge. Maybe we want to cross over this road, this river. So I'll just add a structure. I'll add a bridge starting from here, going through up to this other end. So our intention is to now be able to generate coordinates for the specific points along that geometry I've laid out in a more detailed way that the engineer can be able to interpret and send to their total station or any surveying equipment within the field to be able to stake out the road geometry based on what we have designed in the office. So that basically just shows that you can easily able to also add a bridge structure within your road. So we won't go into the details of that, but just as an illustration. So basically that's the same process which I went through and came up with a detail, which is now in a different proposal that I was calling the final concept. I had gone ahead and maybe added a number of lanes, the intersections and the corresponding junctions at each point where two or more roads meet. So this basically forms the process of doing that. And you can see I went ahead and even add the specific road corridor. So this again will make even the work of the surveyor very easy, the cadastral surveyors. If they need to know the overall area of the corridor, that will require maybe acquisition from the adjacent pieces of land. So you can see the area here on the, again on the sidebar under the right sidebar under the geometry, you can see the area of the corridor plus the overall perimeter. So if you need to acquire this piece of land to compensate it again, because we know land has become a very sensitive issue, especially in the infrastructure project. So basically the process I went through, be able to generate this. So once the preliminary design is got ready and you have confirmed everything meets all the minimum design requirements, the next stage is to link this up with Civil 3D so that you can produce the details and generate the various reports that can allow the surveyor to stake it out and come up with the correct route based on what you have designed on the software. So to do that, we need to link this up into Civil 3D. And the basic level of exporting this into Civil 3D, we use what we called IMX. Alternatively, you can go into Civil 3D and open this entire InfraWorks model to be able to start working on it further. So I'll just say export IMX, then I'll choose the area. So again, I don't need to export the entire model. I only need to choose the specific corridor which I've designed to just minimize the size of the model that I'm using. So that's my model extent that I want to send. Then again, I need to ensure that I select the specific coordinate system that is used for that particular project area. Then I'll click export. So the process of exporting basically sends the road geometry plus the topography into a file format that I can easily open into Civil 3D. But alternatively, I said, if time allows you, you can still go and open up the entire InfraWorks model within Civil 3D and use. I'll just click export. Then I'll now switch into Civil 3D to basically see how we can receive that concept, that preliminary design into Civil 3D and develop it further to be able to generate an output in form of maybe a CSV file that we can share with the surveyor out on site to work with. So I will switch my screen to Civil 3D to illustrate again, to illustrate the process of getting that. So this is my Civil 3D. So again, just to illustrate that it is recommended that when bringing up an InfraWorks model from InfraWorks into Civil 3D, you should use a model, same versions that should be Civil 2020, InfraWorks 2020. Or 2019, just to allow that data transition between the two platforms. So once in Civil 3D, you should be able to see, we have a tab for InfraWorks. So under your tabs, you should see InfraWorks tab. Basically allows you to exchange data between InfraWorks and Civil 3D. So we have done our preliminary design in InfraWorks. We now need to bring it to Civil 3D to just check it further and verify that all the various design requirements as per a particular design standard, whether it's a AASHTO or DMRB or a localized design standard, you should be able to check for each of those parameters that they all meet the minimum design requirements. So you can do that by either opening the entire model as I had mentioned, or you can import now the IMX. So you can see in the top left corner, there is the import IMX where the cursor is. So I click on import IMX, it basically allows me to follow the path and choose where that particular file was saved. So that importing usually takes some few seconds. So I've done it before this just to save on time. So I want to go through it. So I click on the specific IMX file, then I click open. It will open up. But before doing that, again to mention, you should always remember to set the coordinate system. The same coordinate system which you set in Civil 3D in InfraWorks is what you should have set in Civil 3D to allow automatic georeferencing of your model. So this is exactly the same model which I was having in InfraWorks, and you can see the specific area that I selected to bring up. So when I click import IMX, it will basically bring for me the topo surface, both proposed surface of the road and the existing surface, and the road corridor. That's both the profile, vertical and horizontal, the horizontal geometry, that is the horizontal alignment, and also even the assemblies, the specific assemblies, how you had proposed to use it. So in terms of the number of lanes in each side, the shoulders, the walkways, and even the daylighting, as you can see, it has also brought for us the daylighting. So the level of detail that it will bring to you here basically is determined by the template that we use to bring up the model from InfraWorks into Civil 3D. And again, you can see it like reduces my work by more than 50% if I was to do that design with Civil 3D from scratch. So things like doing the alignment, first generating the surface, doing the alignment, vertical and profile. Then after that, doing the assembly, then from the assembly linking up to the corridor. So you can see all of those have automatically been done at once. So what I need now to do as an engineer or as a designer is to start verifying both vertical and horizontal geometry. So this is the same centerline alignment that we had in InfraWorks. So I need to go into the geometry editor to verify that those curves and all the design elements meet the minimum design criteria. So first I need to go to the design criteria editor to check on the specific design parameters based on the codes. Like in this case, I'm using AASHTO. So the minimum radius table for AASHTO, it gives me that for a design speed of 15 kilometers per hour, the minimum radius is recommended is 4. But if I talk about 70 kilometers per hour, the minimum curve radius required is 203. So meaning that my curves must first meet this value, and this is applicable for a rate of application of superelevation of about 4%. If I move to a superelevation of 8%, you can be able to see the curve values increases further. Okay, the same also at widening, what's the method of widening, what's the typical values. So that basically applies for both vertical and horizontal, but if you go to the horizontal value now, sorry, if you go to vertical, you can now see our constant is usually now using a K value, which is just a conversion into maybe some unit rates for the design speed. So like the K value for our design speed of 70 should be 17. And if design speed of 80 should be 26, that's talking about a vertical geometry along the road. So basically these are the design criteria or the design parameters that you should now ensure that our road geometry meets before we are able to generate the points that should be used to stake it out on site. So after that, so we have seen the design criteria. I can now go into the geometry editor and now go into the table to just check the overall geometry of the road. So you can see Civil 3D will tell you the specific curves and the specific tangent points where there are violation. So you can see it tells me that point 1 is a line which is not constrained and its length is 631.68. The next follows is a curve whose radius is 353. Okay, so you can see at 353, what is the minimum radius for that particular design speed that has been defined. So the minimum radius you can see on that row is 100, but the radius that I've specified is 157. So from my design, I'm specifying 157, but the minimum value is 100. But the length of the curve is 353. So you're supposed to check and ensure that all these values in the table here does not give you any warning symbol. So like I can see, for example, on curve at point number 4, it can tell me the radius is 227, but the minimum radius recommended at a design speed of 100 kilometers per hour, the minimum radius recommended is 600. So that's a violation already. So what I need to do, if I can't change the geometry to increase the radius size, I will need to lower this design speed. And therefore, that's why you'll see that some section along the road will be marked by a lower design speed, like maybe at this section is 50 kilometers per hour, just because the geometry maybe did not allow that, or the terrain or topography did not allow the designer to allow vehicles to move at a higher speed. So after having done that, you're supposed to check for each of the specific components. And you can even see, if I come to the plan view here, you can see a very big warning symbol is still warning me that there's a specific criteria which is violated. So I was supposed to check on all of those to rectify them. Also, alternatively, I'm supposed to do the same with the vertical profile. That's my proposed road surface. I should also check and confirm that there is no violation at all with what I've designed vertically in terms of the design speed. So I can go again still to the geometry editor and open a table, and we should be able to see that vertically I was able to, whatever I did in infra was enough to automatically allow those values to meet the minimum design requirement, and therefore I'm not having any single design violation in terms of a warning symbol. So you can see all my curve radius are in the order of 200 and above, and therefore they meet the minimum design requirement. The same also with the K values on this particular column you can see here. So that basically means I've verified and I've checked that all the design requirements as per the required code of practice, they meet the minimum values that are specified. So the next thing before I go further is to now generate the center line points that the surveyor can now put into their total station, or I can push it to them through magnet, enterprise or magnet field, and therefore they should be able to receive that information in their field controller and start staking it out, as you have seen in Moad's presentation, basically showing the process of staking it out. So to do that, you basically require what we call a control point. So control point or a benchmark is basically the reference point that the surveyor will be using on site to be able to stake out the geometry of the road. So like I have the center line of the road, which basically will be guiding the path that the road should follow. But when staking it out or when laying it out, what should be the control point within the field? So basically that should be defined and agreed on, and the client, in many cases, a road agency, should confirm that the control point is correctly defined and correct accuracy being applied. So I will just create a random control point. So I'm assuming I'm having it adjacent to my station 00. So I'll create a random control point using point creation tool here. So I'll say create point. On the top left on your panels, you should be able to see create ground data. So the ground data I want to create in this case is a miscellaneous point manually. But in many cases, it's the surveyor who should communicate to me the control point, so that when I want to stake out from the software or from Civil 3D, it will be referencing that control point with the way it has been correctly defined on site. So I'll say my point should be located randomly at this particular location, just near the start station of the road. I'll just call it control point 01. I'll say control point 01. I'll enter. Then there's a level. Again, I need to know the levels there. It's the level above sea level. I randomly say it is 62.001, for example. Then the next, it asks me to please specify the location. So by default, I think the point's already there. Isn't that I think my point styles, or if I go to the point group, I should be able to change the point visual style to be visible. And again, since that's a process, so I'll just, you can see on my points list here, you can easily see I'm having the point number, easting, northing, and the point level exactly the same way. So if you can go to see under my preview here, that's on the left of your screen, bottom left of your screen, be able to see the point that I've created. So what I may need to do is just to go under my points group and set a style which allows it to be visible. So I'll just go to the point property and I'll choose for it to be visible. So I'll say basic, and I want you to give me the point elevation. I'll say maybe northing and easting, for example. So if I click apply and okay, you can now be able to see my control point appears here. So that's basically, it's a point which I said must be predefined before I start doing anything here, so that when I'll be staking out, we reference it. So that's the control point. So the next thing, we need to now again define the start of the road, still by creating a random point along the start of the road, or automatically you can create point file for the alignment. So Civil 3D automatically allows you to do that. So I can go to the toolbox here, and under the reports, still on that, on the panel, that's on the left sidebar. Under the toolbox, there is the reports manager. So under the reports manager, there is the points here. So for the points here, I can create point list, or I can create radial stakeout points or points in CSV. Or I can alternatively, I can also create points for the alignment. Okay. So that basically allows the software to read through the alignment with respect to the coordinate system that was set and generate for us the points that can be used to stake out this outside there on the field. Okay. So I already done that in this one I'm calling the detailed one. So you'll be able to see I'm having my control point here. I'm having the initial point where the road starts. So meaning that during the process of staking out, the surveyor need what we call the point they will be occupying with the total station and the point they will be referencing, usually sometimes referred to as the backside. So they will put the total station at the start here. Then they refer back to the control point and they proceed in that order, going through and staking it up to the end of the road. So like the software will only give you, if it's a straight point, it will give you the point of the straights. So like the next point will be this one here, where the curve starts. The next point will be at the center of the curve, that is here. The next point will be at the end of the curve, going through up to the end of the road here. So we want to stake it out and generate a report for it. So since they are just randomly created for specific points along the road, we can specify to the software that instead of giving us at only some specific points, generate for us points at an interval. So whether it is 20-meter interval, 10-meter interval, 15, or basically determined by what you call a sample line, the way the road should be sampled as you start from the beginning going through up to the end. So to do that, I want to now stake it out. So I'll go into my toolbox under the reports. I want to do stake out alignment report. So you can see where the cursor is. So if I double click on it, it opens up. So the create reports for stake out alignment report appears. That's the dialog box. And therefore I can now start choosing the specific alignment I want to create their staking out data. So that is in terms of the specific coordinates for the route that the road should follow that will be used by the surveyor in the total station to define that path. So as I said, you need to specify the point occupied. So that's like the start of the road where they will be occupying first with the total station. Then what will be the benchmark? So I said benchmark is the reference point or the control point that they will be referencing when they want to start staking out that project. And again, there are some other angle type. Again, these are it's only the surveyors who will understand this. So whether they want to use turn positive, turn negative, deflection, and the direction. So in this case, we want to use a turn positive, so that they are rotating positive from true north when they'll be referencing the angle. And the station increment, that's the number of sample, and we want to create is 20, and we don't want to offset. So I'll first choose the point occupied, which I said the first point they will be occupying is the start of the road here. So I come and select this start of the road and enter. You can see it tells me the point number. Then I choose the backside, which we say is like the reference point or the control point on the ground, which I'm saying is this one now. Then I need to choose how does it save that file. Does it save it in CSV? Does it save it in text file or any other file format that you're interested in? So in this case, I will save it in CSV. So I'll choose Excel CSV, then I give it a name. So I'll call it stakeout report for maybe alignment 1, 01, maybe based on the name of that alignment. Then I'll click save. Then if I click create report, it will run through and automatically generate for me. So like in this case, you can create for multiple alignments. It doesn't have to be one single alignment. You can create for several alignments whose point occupied and backside point has been defined. So immediately that is done, it will open that Excel file on where those points have been generated. So I'll just switch my screen so that you can be able to see that kind of the point file that I'm talking about. So I'll switch the Excel sheet to be able to see, and even the level of information that it also gives you with respect to the alignment that you have staked out. So you can see it tells me it is the stake out alignment report. Maybe the client information which I've already added, like maybe the general director, the specific authority, the specific guy who prepared it. Like in this case, it is prepared by me. The alignment name, the station range is from Change 0, 1 + 4, 8, 2. The staking out angle, it is standard plus. Remember that information I was specifying. The point occupied, it gives me its coordinate, that is northing and easting. The backside, northing and easting again. Then the station increment, you are saying we are increasing it by 20. We were not offsetting any value. So then after that, you can now be able to see it gives us, for each specific station, it gives us the angle. So this angle here is the angle by which the total station will be oriented with respect to the true north. Then the distance, so the distance, it is still 0 for the station 0 because that's when you are starting. But then the coordinate is that value that is for both north and east. So these are the values that the surveyor will be feeding in to the total station from the start of the road going through up to the end. So if they move from point 1 going to point 2, it is point 1 which now becomes their backside as they take it out from the start going through up to the end. So I can share to the surveyor this file via very many means. So there is the push into the Magnet Enterprise, as you had seen from Moed's presentation, or alternatively, I can also publish this file into BM360. So like if I wanted to save it into BM360, where they can automatically be able to receive this file on site or wherever they are, I'll switch back into Save with D to illustrate how that file can also be shared through, just to enable the surveyor to receive it on site anytime and anywhere where they are. So in the process of, so I hope you can see my Save with D screen. So in the process of publishing or sharing it or saving it, I'll just click to go back here. But instead of selecting my desktop folders, I'll go and select BIM360. So in the BIM360, I'll be able to select the specific BIM360 account. Then I'll choose, so it's this account that I'm calling customer infra. Then I'll choose the project file folder. So within the project file folder, I'm having surveying data. So this data is meant for surveying, or I can also save it under the reports. So I'll call it, this is staking out data that the surveyor should now receive and start using it to stake out. Then I'll just click save. And therefore, in this case, the file is automatically published into the cloud, where any team member that is connected to that particular platform can automatically receive and be able to view and even query in terms of maybe if there are some updates that I've been making with my design or any other changes that could be happening within the progress of the project. And once I've done that also, I also need to share this drawing with the team, of which I want to illustrate the process, but you need to first convert it into a printable format, that is creation of the sheets. Like you need to produce plan and profile sheets, you need to produce section sheets, the artwork volume reports, and what have you in a sheets that can easily be viewed and queried and reviewed by the entire design team. So I will illustrate the ones which I've already done before because the time won't allow that. So you can be able to see I've automatically converted into a printable sheets. So showing me the profile view side by side with the horizontal or plan view. So these are basically you don't need to plot or print, or you can just directly save it to the BM360 where all the changes, all the updates you make automatically will be received by the people. So what I need to do, I'll just say save as to allow me to save it into the BM360 again so that the surveyor will be receiving my drawing side by side with the staking out report the way I've defined them. So you can see the folder here where I am is already a BM360 folder. So again, if I can just illustrate, so you can see it's the local disk C going down to BM360 up to the specific folder I'm calling Civil 3D. So this is where I'm saving the Civil 3D documents. So I'm not saving them in the same folder. So I have the separate folder for the surveying desired output and the specific output for civil design. So then I just click save. And I just say yes. And my file automatically goes into the cloud. So I will briefly switch into the cloud and you'll be able to see how all those documentation were automatically published into the BM360 where the access is now controlled and limited in terms of the level of access which were defined at the project setup. So my information are now being published. So I'll switch briefly again to the BM360, which we all know is now in the cloud. So you can be able to see what I'm talking about. So I'll share that. So I'm now in my document management system that is within the BM360 and it is in the cloud. So you can see under the project files that's on the right sidebar, maybe the Civil 3D, construction standards, the InfraWorks, the reports, and the survey. So like if the surveyor now want to receive this information from BIM360, they just needed to come here. If they click, you can see it tells me the file is taking out data and the specific name that I've given him. And right now we are in version 1, and it gives me the precise time when this document was uploaded. So if there's a change in anything, I'll be able to see a different version, a change in date here, and the specific individual who published or updated it. So that's where the surveyor should be able to receive that information. The same also with the Civil 3D drawing. So instead of sharing mails, doing what and what, you should be able to see that again, they are available here. So for Civil 3D, you can now see it is version 3 as compared to version 1. So we're able to see that all the entire team members should be able to see that the current version is version 3. And if they want to revert back to version 1, they should be able to see even the previous versions and change to them and even do version compare and make changes and what have you. So as of now, it's just version 3. There's still no issue with the project. There's still no RFI and there's still no markup. So if my supervisor or my reviewer had issue with whatever I've been doing, I'll be able to receive all those updates at that particular point. So basically that's how the different design software links, and also they allow you to link up with the cloud collaboration and document management system where we're able to publish and share our design data and design information. And you can also view and even query both 3D and 2D models. So like if they wanted to maybe look at the concept that I started with, that's the InfraWorks model, they can easily be able to go into the InfraWorks folder, open up and just start looking at that particular model. So I think that basically marks the end of what I intended to do up to this time. So as that opens up, I'll just summarize that the process is basically to do a step-by-step procedure from the point you receive surveying and GIS information, you create up your infrastructure model in 3D, integrating both GIS and surveying data in an integrated civil infrastructure model that InfraWorks allows you to generate. So like this is it. So you can see my final concept here is the final concept whose preliminary design I sent into Civil 3D for the detailed design. So all of my design information and the design data sits within the cloud, where all the design team, that's both the client, the surveyors, the contractor, and any other stakeholder within the team, can be able to review and see them. So like if maybe I was doing it as a junior engineer and my senior engineer has an issue with my curve, they would query it by just creating a markup and telling me, first of all, this curve is very close to failing. So they can just create a markup there and start typing that kindly check on the curve radius. So basically it means that though I did it, but it's very, very close to the minimum value specified the code of practice. So basically it's creating a markup and starting to review the design. So then I save the markup, then I can automatically send it to the whoever designed it. Then from there, the design review process now starts, where the information is now flowing very smoothly between the designer and the reviewers who may not be sitting in the same office at the same time. So that's what I intend to do at this point. So unless there is any other question, so I'll stop at that point and maybe we can now take some few questions and answer them before we come to the end in the next few minutes. Zoe?
Thank you, Elijah. Yes, we do have 3 questions. So the first question is from Abdul. He actually asked 2 questions. So the first question from Abdul is, what do you do if you have a short tangent between 2 curves on a road? And the second question is, can you do the hydraulics calculations for pipe culvert structures along a stretch of road with this design software?
Yes, I will start with the last one. Maybe you'll repeat for me the first one. But for the last one, you can do hydraulics. That is mainly, if you talk about drainage and stormwater, InfraWorks can allow you to start doing the concept where you'd be able to even create what we call a watershed. Then after the watershed, you should be able to define your maybe rainfall intensity, then define the return period, and define the coefficient of your discharge. Then from there, you can be able to get the discharge for that particular catchment area. Then from there, you proceed to start sizing your drainage network. So you're able to generate the sizes of the drainage network and develop the design further in Civil 3D, just as you have seen me doing for the road. So repeat the first question, please. I didn't quite capture it well.
Okay, we've got quite a few questions from Olani. The first question is, can I use coordinates acquired by a surveyor from field in InfraWorks as against satellite imagery data?
Yes, I will illustrate that shortly. So you can set coordinate system based on the one that you got from the surveyor. So in InfraWorks, under settings, you can go to the model properties. I hope you can see the screen. So under model properties, you can choose the coordinate system. So it has all the internationally used coordinate systems. So whether you are in Nigeria, Kenya, USA, whichever part of the world you'll be designing, it has all the defined and locally used coordinate system for each of those areas. So like, let's say I'm in Kenya, for example, I'll choose Kenya as the category. Then you see it filters out and give me the specific surveying coordinates used in Kenya. So whether it is the ARC 1960 UTM 36S, ARC 1960 UTM 36 North. So it's the surveyor will now specify this value for you based on the location where the project is being done. Okay.
The second question that we have from Oleni, can we have a brief explanation on sheet creation with customized title block?
Okay, I think the last webinar we did was, must have been in either August or July, where we were going through the details of sheet creation. Because time may not allow us to illustrate that, so maybe we can reach out to you later and take you through the process. But it's also a very simple process, similar to if you have used AutoCAD, the process remains the same. It's only that in Civil 3D is a bit more dynamic than in AutoCAD.
Okay, we don't have any other questions except for one comment from Patrick. He wishes to learn how to decide on appropriate line of sight and generating volume reports, cut and fill balance.
Yes, actually you can generate volume reports. It's also just because of time, that's why we can't capture all those within one webinar. But as in an illustration within the same project I was showing you, there was a volume report that I had generated side by side with the design. So if I can just switch the screen shortly, you'll be able to see with Civil 3D you can generate both the earthwork volumes, that is cut and fill, and you can also produce the pavement structure volumes, that is the base, the sub base, and both finishes of the road, that's whether you're using asphalt or bitumen. You can be able to produce those one in a table and generate them and print them into a format that can be used for the construction process. So maybe just to switch shortly, you'll be able to see a table, a sample table which I already created. So just check on my screen, you should be able to see there is a sample earthwork volume. So still the same in a form of a total in the station ranges, where I define a precise station range. Like if I want to produce volumes after every 20 meters, or after 10 meters, or after 15 meters, then that report is basically what will generate and print and share. So this is a sample. So you can see, if you can see my screen, this is a total volume table. So give me the area fill, the area cut, fill volume, cut volume, and the cumulative volume from the start of the road going up to the end. So that's something which is very, very possible. Any other questions, Zoe? Hi, Zoe. So we may stop at that point if there's no further questions.
There's one more question from Patrick. He would also like to know, can we do pavement design as well using Civil 3D, or is it restricted to road alignment?
So Civil 3D will only allow you to do what we call more of geometry. So that is the vertical profile, horizontal profile, plus the various sections or assembly of the road. But pavement design is usually more of a specialized component of road design. So Civil doesn't do it. So what you need to do once you have done the pavement using the specific codes, whether you're using the TRRL or any other design, you should be able to now start defining this assembly with respect to the pavement thicknesses that you have got. So you can see I'm just having an assembly here, but that information needs to be provided to me by the materials engineer who was in charge of designing the specific pavement structure. So the Civil 3D won't do the design, but you can be able to put those design values into the road section or the road assembly. So like if the pavement from the pavement design, you got that maybe the subbase was 200 or 300, you can now start customizing and choosing those specific values for the assembly, as you can see on what I'm showing the screen. So you can only do geometry design for road and the section design plus a corridor design, then do your earthwork volume, generate setting out data, but you can't do pavement structure design.
The first question from Abdul was not answered, Elijah, so if we can maybe just address that. The question is, what do you do if you have a short tangent between two curves on a road?
Short tangent between two curves? You can remove it. If it's not an important point, maybe you don't want it to remain as a point of intersection within the road, because it can be a PI along the road based on the way the road is to be set out or the way the corridor was defined. If not, you may have to remove it because it may also restrict you. It can become a geometry constraint in terms of trying to adjust the curves. So you can remove it or convert it to no point within the road geometry.
One last question. I think we'll take one last question for the webinar. It's from Patrick. How do you take into consideration the construction time as you make design decisions or road alignment?
So that basically is something else. Again, maybe we'll be showing it in the future webinars. So we have a construction coordination and scheduling, which you can do within Navisworks. So Navisworks basically allows us to perform scheduling and coordination of the project in terms of maybe you want to control by be saying that if this is the overall road alignment that you have, what are the small pieces of the component that the contractor will be able to accomplish within a specified period of time, maybe based on the resources that he has in terms of maybe the labor, the materials, and even equipment. So maybe in the future, we'll be running a similar webinar to show construction, scheduling, coordination, and even management of the project at the execution level. But the specific tool to look for in that particular case will be Autodesk Navisworks.
Thank you, Elijah. We don't have any more questions. I'd like to thank all the participants for joining us. One last thing before we close off the webinar. I'd like to launch a couple of questions, poll questions for our participants to answer. If you could please take a minute to participate in the polls. I'm launching it now. Thank you. The poll questions are live. If you could please participate in the poll questions, that would be greatly appreciated. Thank you. Thank you to those who have participated in the poll questions. I will end the poll now. If there are any other questions that you would like to ask the Ideate team, you are welcome to contact us at info@ideate.mu or info@worldsview.co.za. The recording of the webinar will be provided to all participants via email with a link to view the recording. I thank you all for joining us today. Thank you to Elijah and Moad for the presentation.
Thank you, Zoe.
Thank you, Zoe. Thank you, everyone.
Thank you very much. Enjoy your day further.